Hello, my name is Gary Stafford, and I will be directing you through this course. What I will be doing is creating several videos per section, probably at least 2 to 3, maybe sometimes up to 5 or 6, depending on how much content is in that particular section. In this particular section F1, there will be 4 videos. And how I usually will do this is I will give an overview video that kind of tells you a little bit about everything, if there's any formulas we'll need to know for that particular section. And then after that, now sometimes the overviews are actually 2 videos also, because the content is so much that I would prefer to create the overview in 2 parts. So, but once the overview video or videos are created, then I will create other videos for that section for particular homework problems for this online course, and I will be using the online text. And so if I do use this for my pre-calc class at Missouri State on traditional courses, non-online in other words, then I might have them watch these videos as well. But keep in mind that the books that we will be using are different, but the content is relatively the same. So, but the book that we will be going through with this material is for the Sullivan book. And so, but anyway, so that's kind of what we'll be doing. Like I said, 4 to 5 videos. Try to keep them 5 to 10 minutes each, but I make no promises. Sometimes they take a little longer than I would like, but it takes that to get the material distributed to you guys. And the good thing about the videos is that you'll have, as opposed to a traditional course, is you can rewind. You don't catch something the first time I said, you can rewind it and listen to it again. And so that's the good thing about watching videos. The bad thing is you have to have the willpower to actually sit through them. Sometimes it's easier to hit stop. I think I know how to do this, and you get yourself in trouble really fast. So, but anyway, so what we're going to do is we're going to get started on the F1 distance and midpoint formulas. This is something that is review. As a matter of fact, we'll be doing F1, F3, and F4, and all these are review, and these are prerequisites. When we hit chapter 1, even most of you guys will hit when we hit chapter 1, we'll know that material as well. So, but I would really suggest you to keep an eye on these videos, and because you will get in a pattern. So if you get in a pattern of not watching the videos, when you get to the sections that you really need to see it, you won't be in that pattern. And so you'll try to do your homework by yourself, and you'll get messed up, and then you always try to work backwards. So I would really suggest to keep these videos, watch them whether you think you need them or not, and just to get in that routine. So anyway, so F1 distance and midpoint formulas. The overview will discuss basically 3 main topics: the rectangular coordinate systems, the distance formula, and the midpoint formula. So those are the 3 items that we'll be talking about here. Now, the rectangular coordinate system basically consists of something that we basically have number lines. One's a number line is horizontal, and when we talk about number lines in themselves, they're one-dimensional. Basically means if you have one number, a number on that number line exists only if it's on that line. So, for example, like a number line 0, 1, 2, 3, 4, -1, -2, and -3, and so on. So these are like regular number lines, and I'm pretty sure most of you guys have seen number lines before. So the arrows indicate they go definitely in both directions. So this is what we call a real number line. So any real number could be found. Even pi is 3.14 would be located like where my pointing finger is right there, just past 3. And so any of the real numbers would be on there. So that's a real number line. But if you have a number and you want to point at it, and this right here, well, that number doesn't exist because it's on a one-dimensional number line. In order to make it meaningful, we have to create another number line, and that number line runs perpendicular to this number line, and they intersect right there at the zeros. So 1, 2, 3, and 4. And -1, -2, -3, -4, and -5, and so on. So it's basically two number lines that actually come and they intersect at right angles. But what that does, it goes from one-dimensional to two-dimensional. And so now numbers out here in this space does make sense. So whereas if it was one-dimensional, like I said, this one would not exist. So if we put a point right here, then that number has meaning. And so it's a location on the flat board. That in itself is called a rectangular coordinate system, and because it's on basically a rectangular sheet. And so we have two axes. This is the x-axis, so it's the number line that runs horizontal, and the y-axis, the ones that runs vertical. Okay, so you have the x-axis and the y-axis. They're both number lines, and a lot of people get them mixed up, which one's the x and which one's the y. I just will remember a really kind of an easy way. The x-axis, okay, and the y-axis, okay. Horizontal, because the h in the horizontal comes before the v in the vertical, and the x comes before the y in the alphabet. So x comes before y, h comes before v. So it's on the x-axis is the horizontal axis. So x with h, v with the y. It's silly, but it worked for me, so maybe it'll work for you as well. So these two number lines actually intersect at right angles. Okay? Now where these two axes meet, they meet right here, and it's the point location 0, 0. Every point on the rectangular coordinate system has a location. And this one has a location of 0, 0. The first number in that ordered pair represents the x-coordinate. It has a special name, and the second number has a special name, and it's the y-coordinate. So this point right here is 3, 1 because the x-coordinate is 3 and the y-coordinate is 1. So, but the x-coordinate comes first, then the y-coordinate comes next. And this actually has other names besides x-coordinate, y-coordinate. It also has something called abscissa. That's your x-coordinate. And the ordinate is the y-coordinate. Okay? So the x-coordinate is the abscissa and the y-coordinate is the ordinate. Now, why? I've never heard of these names before. It's probably not, it's probably not uncommon for people not knowing what those are. But it's because this was created by a man named René Descartes. René Descartes was a Frenchman, and he was the one that says, "I think, therefore I am." But anyway, these words came from the French language. So abscissa is the x-coordinate, ordinate is the y-coordinate. So you'll hear a lot of times a teacher will say, "Well, the abscissa is this number here," and you're like, "Well, they're speaking over my head." Well, it's just the x-coordinate. So you're going to learn in mathematics is a lot of times one term that may have 2 or 3 other terminology just depending on which part of the world it was discussed. And so we're becoming global, and so this is the way it is. And so these two coordinate systems, okay, these two coordinate lines, this x-axis and the y-axis, basically divides the plane into 4 regions. And these regions are called quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So any ordered pair that is going to be in this quadrant right here will have the abscissa and the ordinate both positive. Because if you notice, 3 and 1 is positive. Because you're going right, which means you're positive on the x-axis, and you're going up, which is positive on the y-axis. Now, in the second quadrant, like for example, this number right here, the ordered pair -2, 2, notice you went left then up. So left means you went negative, and 2 up is positive. So the abscissa is negative, and the ordinate is positive. And as you can probably tell, any point down here in quadrant 3 will have both the abscissa and the ordinate negative because you went left and then down. and in the fourth quadrant the abscissa will be positive, but you had to go down, so the ordinate will be negative. So that's kind of locations. Yeah, but what if it's on the quadrant themselves? What's the location here? Well, let's look at this point right here. Let's look at that location right there. That's, the x coordinate is 0, because you went just straight down, and then 0, negative 5. Yeah, which quadrant is that in? Well, it's not in any quadrant. It's actually called a quadrantal point. It's fancy words, but that's what they are. It's called a quadrantal point. Basically, it's a point that's not in any quadrant, which kind of doesn't really make sense. We call it a quadrantal point. You think it would be in a quadrant. Well, it's quadrantal point, and that's a point that is not in any quadrant. So, and but anyway, the rectangular coordinate system has many names. It has, some people call it an XY grid, XY axis, just simply a graph. Some people call it just a graphing axis, which that's very uncommon. It's not very formal either. Another big name for it, though, is something called a Cartesian plane. And the reason it's called a Cartesian plane, like I said, it was developed by a man named called Rene Descartes. So take Descartes, take the D-E-S off, and cart, C-A-R-T-E-S, so Cartesian plane. So that's the more common name in today's world is the Cartesian plane. But in America, we probably just call it a rectangular coordinate system. But it has other relations. You probably go to Europe, they probably don't even call it a rectangular coordinate system. They might call it a Cartesian plane. It's just kind of depends on where you're at. Now, so that's the rectangular coordinate system. This most of you guys probably have seen this stuff at some point in your math career. Now, the other two topics we're going to talk about is how far points are from each other on the rectangular coordinate system. That's given by the distance formula. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's the distance formula, okay? It's the difference of the x's squared plus the difference of the y's squared, and take the square root. So you have 2 points, and the 2 points are going to have 2 x coordinates. The x coordinate for the first point and the x coordinate for the second point. So that's what the subscripts are saying. This is the x coordinate of the second point, and this is the x coordinate of the first point. And then you take the difference between them, and then square it, and then do the same thing with the y coordinates, and then add those results up and take the square root of it. But that's the distance formula. You know, that's the formula. I've never seen this before. You probably have, but not in the way that you think. If you look at the rectangular coordinate system, let me take some of this stuff off here now. Like I said, you have these 2 points. One may be down here in the third quadrant, and one may be up here in the first quadrant. It doesn't have to be, but that could be. So this is x1, comma y1, and this one's x2, comma y2. Like I said, each x coordinate, each point has an x coordinate, and each point has a y coordinate. So we want to find the distance between those 2 points. So it's like getting a ruler and measuring that distance between that point to that point. That's kind of what you're doing. Okay. So what you do is you take these 2 x coordinates right here, subtract them, and you find that difference. Well, that difference, guys, is nothing more than this distance from here to here. So here's the x1, and here is the x2. When you this x2 is on the right side of x1 on the number line, and when you subtract x2 minus x1, you found that distance. So x2 minus x1 is the distance of this horizontal dotted line right there. Okay, and then this point up here is the y2, which is the y coordinate of this point up here, and this point right down here is the y coordinate of this point over here. And so this vertical dotted line has a distance of y2 minus y1 because it's bigger. And I'm hoping that everybody's at least heard something called the Pythagorean theorem. Most people have a song that comes with the Pythagorean theorem. It's like a Pop Goes the Weasel song or something like that. but yet a lot of people see that in high school. And but anyway, so what you're doing is basically using the Pythagorean theorem. So you're like, well, how's that? Well, if you know the Pythagorean theorem is c squared equals a squared plus b squared. Now c is the actual distance between here to here. And that's what you really want. So c is that distance. But I'm not calling it c, I'm calling it d. So it's kind of like take the c and make it a d then. So d squared is equals to a squared plus b squared. And then to get rid of that square, you take the square root of the other side. So d equals the square root of a squared plus b squared. But if you notice, a is this one and b is this one. A and b are the other two sides. Well, a is the distance between these two x coordinates here, so it's x2 minus x1. So a is the same thing as x2 minus x1, and b is the same thing as y2 minus y1. If you replace the a and the b with those two items, you have a formula. So really, the distance formula is nothing more than the Pythagorean theorem in disguise. It looks like they're two different formulas. You look at this formula, c squared equals a squared plus b squared. You look at this formula, they don't even look like they're related at all, but they are. It's just a little bit of substitution. So if you take this a and you make it x2 minus x1, make that a right there, that, and then make this b y2 minus y1, and then square the b, so square that, and then put the plus between them, and then surround them with the square root. So there it is. So that's the distance formula between 2 points. So, and in the next one, some of the next sections in this videos in this section, I will actually do examples of these things. So don't think you're going to get through without seeing some examples of these. I will show you examples, but not in the overview sections. Okay. And then finally, the midpoint formula. The midpoint formula is the point directly in the middle. Midpoint, middle point. Get it? Midpoint. So it's the point in the middle. It's the average of basically the x coordinates and the average of the y coordinates. So what you're basically doing is taking x1 and x2, finding that number in the middle, which is x1 plus x2 divided by 2. It's like taking the average, add them up, and divide by 2. And then the same thing with the y coordinates. Take those two y coordinates, y1 and y2, add them up, and that finds the number in the middle. And so the midpoint formula is, and I call it CAPM, and you don't have to. Some people don't do it. Not little m, because little m is going to be for something else. You'll learn that in I believe F3. So midpoint is x1 plus x2 divided by 2, y1 plus y2 or 2. So you can kind of think of midpoint as the middle point or the average point. And if I gave you two tests, and I said, okay, you got an 85 on the first test, you got a 95 on the second test, how did you find your average at that point? You would know what to do. You would say, well, I'll get 85, and I'll take 95, add them up, and divide by 2. It's the same thing with the abscissas and the ordinates. So if you want to find the average, the middle point, so you take add them up and divide by 2. So it's the same concept. So, but here's the overview. This is it for this one. And but like I said, each section we'll talk about an overview, and then I'll divide the homework basically up into sub videos, and then do videos of each one of those. So by the time you do get ready to do your homework, you'll be ready to go. So, but like I said, don't slack off on watching these videos, especially when we get farther on in the book. And you need to start that routine early. So even though you may see this, say, I know what I'm doing, I know what I'm doing, just start that routine so you get into that routine and know what to do. So, but anyway, so my next video will be talking about some problems out of that. So thank you for watching.